Welcome to the No Ordinary Cloth podcast, where we explore innovations bubbling away at the intersection of textiles, emerging technology, sustainability, and craft. I'm your host, Mili Tharakan, a textile researcher and innovator. Welcome to the No Ordinary Cloth podcast, where we stitch together a rich tapestry of textile innovations, one episode at a time. I'm your host, Mili Tharakan, a textile innovator and researcher. And in this podcast, you get a glimpse into the future, shedding light on innovations bubbling up at the intersection of textiles, emerging technology, craft, and sustainability. Join me as I sit down with pioneers who are radically reimagining the very way we make, use, and remake textiles. What if the sewing machine was about to become obsolete? In this episode, we sit down with Cam Myers, founder and CEO of CreateMe, an industry pioneer using physical AI, robotics, and advanced adhesive technology to reinvent apparel manufacturing as stitch-free, automated, and radically faster than traditional sewing. We explore how this innovation is solving one of manufacturing's toughest challenges, that's automating the apparel sewing industry, which has remained stubbornly manual. From understanding the complexity of fabric physics to reinventing garment engineering from the ground up, Cam takes us inside the future of stitchless apparels, onshored microfactories, and why now is the pivotal moment to finally automate the sewing industry. Over the past 6 years, Cam has built CreateMe from concept to being a pioneer, holding over 25 patents for apparel automation technologies. He's an entrepreneur at core and has successfully built and scaled several tech and e-commerce companies in the past. Whether you're curious about robotics and AI, apparel construction, or the future of manufacturing, this conversation will shed some light on the bleeding-edge technologies needed to construct your everyday t-shirt autonomously without a single stitch. So let's meet Cam and learn about the technology that could potentially replace the sewing machine. Hi, Cam. A warm welcome to the No Ordinary Cloth podcast. It's so exciting to have you here with us to help us understand how cutting-edge technology is quite fundamentally transforming the very way we construct garments. So when we talk about making garments, there are two things, usually, cut and sew. And it sounds so simple, right? Garment construction, it sounds very simple, but it's garment engineering. And it's this beautiful dance that I see between fabrics and hands and a sewing machine. And the sewing machine has fundamentally been the way we've constructed garments. Well, first with hands and then sewing machine, but sewing was the method of doing it. And a little aside, actually, I found out yesterday, I don't know if you know about this, Cam, there's a sewing machine museum here in London. And as part of their collection, they have one of the very first sewing machines that was invented by the Frenchman Barthélemy Thimonier in 1839. So I was like, I have to go see what this looks like. But the sewing machine is a really complex piece of technology and totally transformed the garment making industry. And here we are today, almost 200 years later after that invention, with you to talk about how your technology is going to enable garment making that is completely stitch-free and hands-free. So it's an autonomous tailoring platform aiming to once again revolutionize the future of garment making. So it's very, very exciting, Cam. Thank you for joining us. Let's dive straight in. Before we talk about your business, you're on a mission to redefine how apparel is made in the 21st century, right? And that's no small feat. So before we go into how you do this, let's paint a picture for the listeners about what the current apparel manufacturing process looks like. What happens there?
Well, first of all, Millie, thank you very much for having me on your show. Really excited to share what we're doing with your listeners. I'm Cam Myers. I'm the founder and CEO of CreateMe. And as you said, our mission is to redefine how apparel is made. I think if you took a sketch of how the industry looks today, I would say that the apparel industry is the poster child for offshoring. It's the industry that's really driven that as a global economic model. So, apparel is fundamentally, for the better part, made with sewing. It doesn't have a lot of automation. It's very much, and this is something that for people outside the apparel industry, they may be less aware of. It is fundamentally all made with human hands. It is very different from really most other large-scaled, manufacturing industries that have high levels of automation. Certainly, cutting is a step that does use automated steps, but by and large, beyond cutting and certain finishing steps, the actual assembly and putting together of garments is manual. It's a very complex, diverse supply chain. When you think of things sort of upstream, where you get the materials from, I always think that the example that really typifies this is, say, cotton. The United States is in the sort of top 3 or 4 largest producers of cotton textiles in the world still today, but really most of that goes offshore for milling and then put into fabric. And then, there's this kind of boomerang trade where, it's milled and then it's assembled and sewn into a garment, and then it comes back to the US. So very complex when you think of fabric and then all the other hardware, trims, rivets, buttons, zippers. It's a diverse supply chain that's happening in multiple countries, lots of different handshakes, and it's done at an enormous scale. I mean, probably that's the last thing I would say on that point. By most measures, it's the second largest industry in the world from the point of view of manufacturing output, because everyone in the world is a customer. And so, the statistics I've seen is typically the total global output of apparel is between 100 and 150 billion units per year. So after chipsets and kind of transistors, it's by many measures considered to be the largest industry from kind of industrial output. So it's an enormous, complex industry.
You absolutely hit the nail on the head when you said it's very labor intensive. So according to the International Labour Organization, it's believed that about 60 million people are employed in the apparel sector alone. So why is that? Why has it been so hard to automate sewing?
Yeah, I think you can sort of look at that from kind of 2 angles. One, in general, and you can take this perspective across different kind of manufacturing industries, looking at assembly or automation for things that don't have stable physics. It's not a sheet of aluminum, that kind of thing, which textiles obviously are. They move and bend and flex, and they move and blend and flex across a huge variety of textiles that people use. They have different physics in terms of the flexibility, the grip, all these types of things. That is something that's not very nice for automation. So that's why it is still an industry that fundamentally is very high in labor. I would say the second reason, and perhaps a more nuanced and interesting reason, is that sewing in of itself, from a first principles engineering perspective, is actually quite hard to automate. And so you can think of that for probably really two reasons. One is that if you think about software systems that are used in industrial automation manufacturing environments, that have to use software to perceive, like the human eye does, how something is moved and orientated. Doing that in a static, stable environment is one level of complexity. So you think of like how metal would be welded in an automated process with a car is kind of one concept. The next level of complexity is actually doing that under motion. And if you think about what sewing is done, the human eye and hand coordination, you're bringing fabric together, you're edge aligning it, and then you're having to keep it in edge alignment under motion. So that adds a lot of complexity. The second reason is because it requires 2 sides of access. If you think about a sewing machine having a cavity where the bobbin is, it's punching between 2 pliers of fabric. That act of requiring access makes it a lot more complex to interplay with the toolkit that you would use in automation. So things like vacuum systems, molds, conveyor systems, these types of core tools that you use in automation don't play nice because you need access from 2 sides. So, I can talk in a minute about how we approach it differently, but those 2 things are really big constraints that actually say it's a lot harder than just saying, hey, can I put a sewing head on a robot? Will it work its magic? No, because the environment that you need access on 2 sides and you need to have things working in motion actually make that a very complex engineering problem.
Absolutely. It looks so simple, but you explained so beautifully that it is such a complex engineering work going on over there. So with that picture painted, tell us about CreateMe and the problem you're solving for the apparel industry and how you're doing this.
Our technology platform stack brings together, three core technologies: the use of, robotics, which is certainly having a renaissance at the moment; the use of proprietary software, which is built on a foundation of some algorithms that come from, machine learning, computer vision, but really where this is really going is into the use of physical AI for the perception so that a robot can understand at the level of human dexterity that human hand eye coordination with. But the real unique perspective, the real unique part of the technology is the use of adhesive and the assembly process. It's a printed form of adhesive, meaning it's a little dot disposition that's put down with a little break. So it actually mimics what a stitch file looks like. It's a stitch file. It's not a continuous line. It's points on a piece of garment that it's punctured, so it has that stretch and cover and flexibility. And it's this use of adhesive that sort of unlocks the platform by which you can look at automation. It's a very efficient method because it can, it's all static assembly, what I was talking about before about complexities of motion. If you think about how something gets bonded, you apply adhesive and you stamp it to bond it. And it requires only one side of access, so the toolkit that you use. So it's a very efficient method. We actually take inspiration from other industries that have gone through the journey of very high levels of automation. So if you think about, consumer electronics, a Nokia phone 25 years ago that would have rivets, soldering, fastening, but you take your iPhone or your Samsung today and it's printed laminate adhesive that builds the phone. So those are some of the properties. And look, the last thing I would say is adhesive is used today in the apparel industry, certainly footwear. You think of all your sports shoes, that's used with adhesive. It's a much more efficient assembly process. And certainly in apparel, seam tape is something that is used. If you think of your Nike Dry Fit or Lululemon leggings, but they have constraints because it's tape, it's a little bit more bulky, it's a little more heavy, it doesn't move and flex. This is taking a principle that mimics a stitch pattern, which is good. It has all the efficiencies and properties that you would have with a stitch, but it doesn't have either the drawbacks either, and that can show up from a consumer standpoint in terms of being a lighter gram weight, better breathability, even higher flexibility than a stitch file, but also it's more efficient from a manufacturing perspective as well.
Tell us a bit more about the adhesive. So you're gluing fabric together. Of course, this is going to, survive in washing machines and all that. But what happens when you want to sort of take it apart? Or, you pick stitches and you take things apart if you want to repair it or do something to that garment. What happens in this case if it's glued together?
The process that we've developed for the assembly has, from a washability, strength, durability perspective, it's at parity or actually stronger than thread. And we use some adhesives that have been on the market for a short period of time in our assembly process, principally used in women's intimates. It's a product that uses the printed bonded approach because it's a much more comfortable product. So the consumer has driven, that pull. But to your point about assembly to disassembly, what we realized when we started the company is, hey, actually there might be some very unique things from the point of view of disassembly that you could do with adhesive that simply isn't possible with thread. And so over the last three and a half years, we have been working with the University of Warwick in the UK and have developed our own proprietary adhesives. They have a property which is called thermoreversibility, which is basically a fancy way for saying that you can use heat to activate and bond it at a certain temperature. And then at another temperature above wear and tear in recycling, you can delaminate or debond it. And so that's very interesting. And that's a principle that's used in other industries that use adhesive, like e-waste, and you can make the process by which you can scale recycling a lot more efficient. Because one of the hardest parts of looking at the flow with recycling is that assembly and that separation of waste streams, so that you have polys in one place and cotton in another, or hardware, in terms of zippers, that kind of thing. And there's a lot of talk about recycling in apparel, but really a lot of it is happening in that post-industrial waste stream, meaning scraps that are from the factory floor, because they know it's unadulterated. They know, hey, this is all cotton or this is all poly. The conundrum, or how you deal with disassembly for a garment, is a lot more complex to know how you manage the waste streams. And it's hard because stitching, it requires de-stitching or shredding. All those processes aren't so efficient for garment separation of different textile types.
Adhesive is one part, and then this is a key part of the manufacturing process. You very quickly mentioned physical AI. Could we kind of go a little bit deeper into that? Because the physics of textiles is so complex. You mentioned it earlier, the drapability of different cotton versus silk versus linen is so different. So it's been actually really difficult to even make digital textiles and get that true feel about that fabric digitally. So what is physical AI, and how are you using that in this manufacturing process?
It's a great question to kind of double click on. So I think in textiles, in apparel, one of the highest problems of complexity is the notion that you have this kind of tension between extreme scale and extreme need from a solutions perspective for high manufacturing output, and also extreme variability. And variability is across several dimensions. What you talked about, the physics of fabric. It's not just that the physics of fabric are not stable; that they're infinite almost. Yeah. Different types of textile. Right? So what a cotton at 140 gram weight, how that behaves, the tensioning of how it's woven, and what the stability of that fabric. Does it curl? A lot of fabrics do curl. That's also something that doesn't play nice with robotics. Is it a net? Is it a woven? All these different things have different properties. And so, probably in the last 2 years or so, there's been this kind of leap forward in artificial intelligence, moving beyond, what people mostly talk about it in terms of as from a software perspective, chatbots, that kind of thing, and starting for it to move out of the lab into how it can perceive things in three-dimensional space, so that it can almost understand with the properties that the human eye does, and that's one model or format, so it can understand how something that doesn't have structure can move, how it can move in three-dimensional space, but also other properties of the physical world. What does it feel like from a tactile? You can have tactile sensors. What's the force feedback if you pick something up lightly versus with a high grip strength? Will it move between the fabric? Will it move between the grippers? These are techniques that are starting to come into the fore. And so I mentioned that we have this kind of toolkit of software that we use in our assembly process. Slightly more mature methods rely on sort of machine learning, so that more a rules-based assembly approach, and that can work for certain manufacturing steps. But really, the high level of human dexterity, if you see what a tailor does, if you had a camera looking at a tailor and sewing something, a very fine tailoring task, that's not a rules-based process. There's a lot of feel and feedback that's going in. Maybe you're flexing the fabric as you're moving it around a joint. These types of concepts, they won't play with a sort of machine learning approach. So said another way, you can get a level of automation with machine learning, but to really step in to solve the more complex joinery that you have once you move away from assembly that could work in two-dimensional space, once you move to assembly that needs to happen in three-dimensional space, things like a neckband, things like a shoulder joint. There's a very, the tailors in your audience, if you take apart a sleeve to a body, it's a very complex joint. It's irregular, it's soft. Those types of techniques, as well as moving across the variability of fabrics, it's a very, very complex problem for robotics to understand. We're just at the kind of bleeding edge of it. But some of these tools, these new models to understand how to perceive, for a robot to perceive, which a human can do easily in three-dimensional space. And these are some of these software techniques that are really accelerating the potential for this type of assembly. And it's going to bring a lot of benefits in terms of standardization. I think every consumer knows, if you buy from even the same brand, a t-shirt or a pair of denim, the same brand, but it shows up at a different retail location, and you overlay one t-shirt on top of the other, one pair, a 34 denim jeans is not the same.
Yeah.
And that's, complex. Humans are building those things. Standardization is going to give people much more clarity that they're going to get the same product wherever they are in the world. And I think that's a really exciting thing. I think and that's why consumers believe in brands, because they know they like, the same product, and be able to stand behind that more. I think is one of the really exciting possibilities that's going to come as this technology gets adopted more widely.
I loved how you talked about the feel and feedback that Taylor, works with, and your robots are sort of trying to mimic that in a way, if I understand correctly. How are you achieving that?
Yeah, so they talk about, in a software perspective, having multimodal models. It's quite an alliteration. So that sort of information coming from multiple sources. And so, you may start some of these new models as they're called vision language action models. So it's a perception, visually of how something shows up. So, some of them are also using tactile models, so that these are sensors actually on the end effectors, on the little grippers on the robot that can feel that feedback. And we've developed tools that actually mimic, and there are also some materials or mechanical ways that you can do this. There's certain materials that kind of can grip in one direction and not grip in another. You think of like a gecko, right? They have properties on their little pads that can have high friction in one direction, but then if you lift, it doesn't have friction. And so if you think of, to your point, of what a tailor has to do, they have to flex and move fabric. And so we can use some material properties, some material techniques with our software to be able to flex and move fabric just in the way that a human does with easing. So we actually have technologies that can mimic, and we have patents around technology that can mimic, the very small micro movements.
Wow.
And that's something that's very hard for a robot. If you think about a human, if they're building something in sewing, and there's a little, a bit of edge that's a little longer than the other, you can kind of push it around so that it'll line up. A robot, typically, the way they're built is much more, rigid. And so, these are some of these kind of techniques that we developed that will give that last little bit of human dexterity, which is everything between something that's mostly working and something that is 100% working.
Wow. I mean, that sounds like a very intelligent toolbox that you're building right there. Are there any limitations to the kind of materials that can be used with your system?
Yeah, so we've tested our the adhesives that we use from a material compatibility perspective across about 100 different textiles. I think sometimes you can see some issues if there is some type of coating between the surface of the textile, which could impact the embedding or the wetting of the fibers. But it hasn't been really anything significant because, as I said, it works very well across around 100 different textiles. It's not to say that, where there is a barrier, that there isn't a way to address that. It's just, we haven't needed to spend the R&D time because it works so widely. So it works across synthetics, it works across organics, it works across very fine fibers. So the temperature is about 50 to 70 Celsius. So it can work with, silks or organics like cashmere wool, lamb. So it's very, very wide in its application. And that's different from the mental model that a lot of people have, with using seam tape adhesive, which is kind of much more restricted to sort of high curing temperature, synthetic fiber. So it's got a much broader, remit that it can work across construction as well. That's probably the other important thing. So it can work across wovens and net. So it's not sort of defined that it can only work on, t-shirts. We haven't focused as much on it with wovens, but it could be just as performant with an Oxford shirt or, something like that.
We talked about bonding being used for the seams. Can it also be used for adding things like trims and embellishments onto the garment as well?
Absolutely. And, we on our website, we have a whole light box that shows how some of these techniques show up. So for your audience, if they're interested, they can go, on the bottom of our homepage has a light box that shows both across garments as well as embellishment techniques. So yes, we've actually pioneered and developed techniques that can be used for embellishment. In fact, we've developed patents around that. So we can do different treatments, and so the adhesive can actually be used as an embellishment effect. It has a sort of a sheen property to it, so it looks a little bit like a sequin actually, which is quite cool. And because it's a CAD-driven process that's working off almost like a CNC, a gantry process, you can create linear and non-linear geometric patterns. And you can do all these kind of surface level treatment processes with the adhesive as well. So that can show up in terms of things like laminating fabric. So literally from a design point of view, doing things that don't translate or aren't possible in the same way as sewing. So you could have, if you think about a cocktail dress or some kind of quite off-kilter stylized t-shirt, it could have layers of organza fabric. And it could move and have a lot of movement, and that can be quite exciting. But it can be sort of almost, we use the kind of metaphor of spot welding. So it's still kind of all together, but has the movement at the same time. Or you can do other kind of interesting things with the adhesive in terms of very fine tailoring techniques. It might take, sort of tens of minutes, certain kind of pinch pleats or knife pleats or other kind of more three-dimensional pleating. You can use the adhesive and do that in sort of tens of seconds. It still has some human element to putting it together, but much, much faster than how it would be done with, conventional thread. Or lastly, you can laminate fabric. So meaning, a fabric conversion. How do you take different layers of fabric and bridge them together, whether it has, sort of batting or something in between, and it can look like quilting, but be much more minimalist because it doesn't have any threads. So yes, there's although our focus is on kind of big volume categories, there are some really interesting things. We work with some fashion houses about techniques that could show up from a more of a design, PD sort of audience, and how that shows up for the consumer as well.
So the automation system that you have right now, what kind of garments lend themselves for this process at the moment?
High volume garment categories are certainly where we're focused in the sort of midterm. So we're commercially live with women's underwear. As I said, we picked that category, intently because it's already a category that uses bonding in the digital form, but it's a more manual assembly process because it has benefits to the consumer. Our second product is in t-shirts. We probably will look at other variations of t-shirts in terms of, polos, how you integrate a soft collar into that, probably over time, other high volume consumer staple categories like men's underwear, those types of categories. What I would say is the vision is very much about having a lot of variability within a parameter of a garment. So we pick something like t-shirts. It's a digitally driven manufacturing process, meaning it's obviously driven from the CAD. It's obviously the workflow that factories already use. They use CAD, they use cutting systems. But we continue that through the entire assembly process, whereas in a traditional factory, that would be moving them from the cutting room, to sewing. And so because we're tracking things the whole way through, that variety is very much playing into what we can do. So what I mean by that is, a brand might have a classic t-shirt, a classic tee, but to move across the micro gradations of, I want a big and tall, I want a athletic cut, I want a slim fit, I want to have smaller variability in terms of a pocket square, I want different widths of neckbands, I want to have a long sleeve t-shirts. All those smaller gradations that still fit in what is fundamentally called a t-shirt, we can build and develop very flexibly. And what I mean by that is the tooling that we use is not defined to, say, for example, a particular size. A lot of factories, a lot of ways that traditional, more analog manufacturing is you have different fixtures and jigs for different sizes. And that means that, you look at building things within the 6 core sizes from double extra small to double extra large. But hey, this is a world where there's lots of body shapes, and if you want something that might bleed more into tweens or go up to triple or quadruple or 5 times XL, you see where the shapewear world has moved. They've understood the market that you want to have half sizes and a broader range. That's the consumer side, actually making that the sausage work on the manufacturing side. That's not very easy. Our tooling is designed that actually the tool will adjust so it can pick something up that's extra small or a 4XL, that type of thing. So that's where we play from the point of view of offering lots of variation for the brand and manufacturing audiences.
I love the granularity that you're able to bring to automation. Wow. So how big is the system? I'm just trying to imagine if this is a new, manufacturing process. What does it look like if I walked into your factory?
Yeah. So we have sort of trademarked the architecture of our tools. And the reason we did that is there's a lot of thought to your point about like what's the size, what garments can it support, that kind of thing. And so when we built our technology, we said, how do we build a platform that deals with the velocity and the flexibility? And how we approach that problem is we said, well, there are actually many parts of the assembly of a garment that are common. So whether it's a t-shirt, an underwear, for men, for women, a crew neck. And so we call this architecture MIRROR. It stands for Modular Engineering Robotic Assembly. And the principle behind that is we standardize what we can build in 2-dimensional space. So if you think of a garment, whether it's a t-shirt or a underwear or a crew neck jersey, there are parts of that are the same. You're having to do a cut step, you're having to build panels. And so we said, let's build as much in a common architecture. So when it goes into a new category, when it goes into t-shirts versus women's underwear versus men's underwear, it's not the entire system that's changing. It's a cell at the end that does the 3-dimensional parts that are peculiar to that garment that change. And so I say that from the point of view that there's a common architecture that you would see if you went into one of our facilities, that we use common tools across garments. So in, for example, t-shirts, it's about a 1,200 square foot cell. And I apologize, I'm originally from more of the Anglo sphere, but I've been in the US enough that I've kind of trained up with the square meters. But that would be about a 1,200 square foot cell that would be able to do about 1 million units of capacity on a 5-day, 3-shift model. Whereas for women's underwear, it's actually a lot less than that because you build a lot of the garment in a single ply form versus t-shirts. With 2 plies, that would be about 550 square feet, for that footprint. And again, would also do about 1 million units of output at a mass production level.
Yeah, let's talk about the time that this process helps to cut down in the manufacturing process as well. Could you compare from traditional sort of CAD to it being in the store versus your production line?
Yeah, so from an order to delivery perspective, what we're going after is a 7 to 21 day turnaround time. That's obviously very different from offshore ordering, which could be 45, 60, maybe more days on a boat. Even the air freighting from ordering it, if it's overseas, that could still be sort of a 3-week time frame. But once you put the whole order sampling to delivery process, you can easily be be talking about nine months. This is a much shorter, 7 to 21 day, turnaround time. And then in terms of velocity, we talked about 1 million units, but to kind of break that down to a more digestible kind of unit of measure, we're looking at sort of mass production speeds for in women's underwear, about 250 units per hour at mass production, and for t-shirts about 220 units per hour, and that's orders of magnitude, far faster than sewing. Some of the stats we've seen is what we're modeling is about 20 times, faster than a sewing process.
Wow, that's amazing. How do you envision this sort of scaling this technology up? Are you creating modular parts that you sell out to manufacturers, or are you selling like a machine in a box kind of thing that people can take away and install and start, press play, get it running? What does it scale up to be? And, tell us a bit more about the sort of micro factories of the future that you've been thinking about as well.
Yes, we have a 35,000 square foot facility in sort of the Fremont area, which for those overseas, that's sort of where Tesla's main factory is, in the Bay Area. So we're in a suburb of that in San Francisco. So we can actually run pretty decent capacity for actually quite scaled, piloting. I think we can fit about 20 underwear lines that will be producing 1 million units. So that would be, something that we would step into if we would scale up that many systems. I think it can fit about 8 t-shirt systems, so that'll be about a million units. So we will pilot out of our facility, and then in terms of deploying it to the customer, that we're talking with brands and manufacturers. Both have to be there at the end of the day, because brands want to understand with their supply chain, the production scalability. That's obviously where manufacturers have been really dynamic in terms of investing in that scale. But they also want to know from the other side of the coin that that the brands like this technology have trialed it. So we have to kind of talk with both. And then in terms of deploying the systems, we're going to focus on deploying the systems probably first in the United States. And then we're going to look at near shore, near the United States, and similarly, in high wage rate places, this model sings when it's kind of close to these big consumer markets, whether that's in places like Japan, South Korea, or in Western Europe. And so we will focus on exactly to your question, these kind of it is a factory in a box. It's a very efficient manufacturing process. There are new techniques to learn with working with adhesive versus thread, but it's very efficient. So you think about factories that have to have spooling for all these, and have safety stock to cover all these different colors when they move between garments. That all completely goes out the window because it's translucent. So you can move across garments. This kind of high flexibility is pretty cool. Now, you asked something very interesting in your question was, well, what about for a component of assembly rather than kind of the whole thing? That's something that actually a lot of brands and manufacturers are interested for, what I would call kind of high tailoring. So it's not about actually building a full garment. It might be more of a universal tool that can do assembly of parts of a garment, whether it's belt loops on a trench coat or pocket. Those are things that we are looking at as well. Like potentially, can we offer a tool that's more universal but less in scope? It's not building an entire garment. But I think our focus initially is on very high volume categories. As I said, women's underwear, t-shirts. It'll probably be another big consumer staple category after that. And the last thing I'd say is this idea of providing these sort of systems in a box. There's less operational overhead for a brand or a manufacturer to deploy their systems in countries and environments where labor has got very expensive for sewing. So it's not just about automation in the sense of high wage rate countries there's a high cost to labor. It's actually more decided and specific than that. Sewing is a skilled art. And people outside the apparel industry may sort of think, it's a minimum wage thing. It really isn't. It's a very skilled, takes a lot of time. Because you have this concept of static assembly, you don't have this, which takes years to train someone to be very good, this kind of human dexterity, this hand-eye coordination. That's not required with this process. So it actually opens up a much larger labor pool that can get involved with these types of products. So it opens up the ease of training. Because every if you think of a sewing person in a factory, they talk about days to train because you get the rote and repeatability for a specific type of t-shirt, and then there's a ramp period with a new t-shirt. That's compressed down to less than a day because there's no dexterity involved. It's all static assembly processes. And so that's a huge part of what this unlock is that makes it very exciting for customers to get involved. And then probably the last customer type I would mention is, the print on demand world, which has obviously had a huge sort of growth in the last 15 years. There's really advanced automated printing systems, the types of companies that play into the licensing world, the embellishment world. That's all near to the consumer produced product. It makes sense when you have all these demand signals from licensing and sport, meme, all these kinds of things to do that very close. Now that's very much an on-demand embellishment. Well, wouldn't that play nice with on-demand assembly? You don't need to have huge factories or warehouses of blanks. You can produce it. So that kind of vertical is also very interested in our product. It makes a lot of sense. And the operators that work on these printing machines, it's the same labor pool can work on the assembly process because, you think about platen, you put a t-shirt on that to be printed, same type of process for our assembly steps. You're putting a piece of fabric in a place to be bonded. So it's very, very aligned for that market as well.
I see a lot of opportunity, like you said, for a lot more people to be trained up in using these new tools. What does that training look like? What kind of skills do they need to, what are the new skills that people need to have to be able to work in these new factories of the future?
You have certain people that, I would put in the workforce class of kind of technicians. And then you have sort of operators. And, I think that's a parallel, a similar process. If you think about a textile printing facility, there's people that have to work with the changeover of the consumables of the ink. The same thing. So there's, in working with kind of chemistry and how you, at the end of a session, flush that out. And obviously there are still, cutting tools, there's consumables for that. That technician workforce is pretty trained. It's a new set of skills. There is its own form of complexity. Dealing with chemicals, dealing with adhesives. These are all very stable and not harmful chemicals. But there's curing time. If you don't handle the adhesive in a certain way, it's going to there's a window in which you can use that. So there's a skilled technician level workforce, and then I think there's a broader operator-led workforce that affords a much bigger universe of people that you can go out to. So as I said, there's people that are doing kind of platen type work, how you put a piece of fabric to be printed, very similar kind of training. But really anyone that is working in the environment of, warehouse workforce, type labor can very easily come into this manufacturing environment. We talk about, days to train is often a stat that's used in apparel manufacturing. We're talking about, in many cases, 1 to 3 days, but even in some cases less than a day. Whereas, in sewing for a new process, you could be talking, more than 15 days to really get that full efficiency going. So it opens up a big labor pool. And I would say, anyone that's working in the warehouse, e-commerce, type of labor force is going to be, very adept to moving to this and will be exposed to actually much more, technical knowledge in terms of working around robotics and machinery that is much more sophisticated actually than what you would see in a typical warehouse automation space where they have autonomous mobile robots. These kind of robots can understand how to move and work around people, and frankly, a lot more sophisticated. And so, it's definitely a good curve of exposure, to technology, but it's the kind of the opening to start is a very broad universe. And that's something I think the manufacturing partners that we've talked to have been very interested in, because what I hear from the very large OEMs overseas is, hey, if I wanted to go into, even centers that are known for textiles like El Paso or, parts of North Carolina, it's not easy just to say, hey, I want to find 1,000 sewing operators. The other thing, of course, is sewing around the world, but perhaps even more in the US, the average age of the workforce is very old. I think I've seen stats somewhere between 55 and 57 is the average age of the existing sewing labor force. And in the United States, it's certainly not as high as that in parts of Asia, but directionally, it's all moving in that direction. There's certainly an age problem, and I think this opens up a much broader universe of people that can work on this. And less roads, it's less road kind of work, which is I think why people, understandably, it is not easy work sewing. Like if you see it, it's I always say it's like the Adam Smith sort of fan channel, because it's like literally the division of labor is what apparel manufacturing, and one person just doing the one person, and the variety of work that would happen in our facility is much broader as well.
Cam, why is now the right time for this technology?
Yeah, I think there's, we've been thinking about this problem for quite a long time. And I would say, we started the company at the end of 2019. I would say the apparel industry is much more attuned than many other big industries to the challenges around supply chain shocks, tariffs, that kind of thing. So I'd say the apparel industry has been quite smart thinking about this, because obviously, at least in the United States, you had the tariff kind of shocks in the first Trump administration, but also you had people that were feeling that, places like China were getting too expensive. And so, people flying to Vietnam and things like this. Well, look what's happened. A singular sort of strategy for geography like Vietnam maybe wasn't the way to go. You need to sort of manage that risk. And so what I hear from a lot of supply chain leaders and brands is the notion of moving away from a purely low-cost supply chain to a more de-risked supply chain. And that's obviously come really into fore, since April, since we saw these kind of tariffs across the board, across really all countries in the world as a reset. So I would say certainly that this kind of has come a lot more into focus post-April, and the notion that it's not about kind of de-risking to one geography, it's about having more of a matrixed approach. Still obviously a lot of apparel is going to have to be made offshore to make the numbers work, but maybe moving away from like an 85 to 95% offshore to maybe more like 70% offshore, 10 to 15% onshore, 10 to 15% nearshore. So I think that's one of the big reasons is this geopolitical thing, with tariffs. I think people have seen a lot with the supply chain shocks over the last couple of years. Not just COVID, we've had the stuff with the Red Sea, with the Houthis, we had, I think also, there was a big tanker that literally got plugged in.
Stuck.
And people realized that this is bad. Now, so many other reasons I think have really kind of come to light, to your point about kind of why now, is I think the technology has moved a lot in the last couple of years. The hardware cost curve has really come down on some of the componentry. There's really good standardized platforms for robotics. That's certainly a reason. The software in terms of physical AI, that's moving at an incredibly fast pace. And so, I always get reminded by my team, it's the worst it will ever be. And that curve of how, understanding how different fabrics move and that's accelerating at a huge clip. So even 12 months ago, it was nowhere near, where it is today. So that is a big thing. And I would say probably the more interesting reason is I think there's a growing awareness. I think it's been stimulated by things like the tariff shocks. There's a growing awareness that it's about time to relook at the business model side. I think the really smart people in manufacturing and in brands are really focusing in on that. And what do I mean by that? What I mean is this is a business that has been very conditioned to manage around low cost, but you have this natural effect of when things are very stretched out from a supply chain perspective, that the signaling between demand and supply is not particularly great. So I think as an industry average, it's about 65% of what is made is sold through. And so moving the sell-through rate from 65 to 70%, 70 is 75, that's really important from a waste perspective. And I love this idea that you can think about waste, obviously from the environmental perspective, but also, economically. And so what can help drive a better sell-through? It's better signaling, better kind of tactics between your orders and when you can have them available. You don't need much safety stock if you can replenish, faster. And so you can have the right thing for the consumer. And that comes with proximity. It comes with having things made close to the consumer. And I think if you look back 30, 40 years, the sell-through rates, when a lot more was produced in Europe and the US, it was 65. I think I've seen numbers in the 80, 85%, range. And so I think that's a really other important part of the why now is people are realizing that producing things close to the consumer, and you need automation to do that. You can't, the economics and the labor availability don't work. But if you can produce things close to the customer, that's a much better outcome, obviously for the environment, but also for the industry, writ large. I think that's really starting to come into focus now, and that's you've got to line more than one thing up to get these movements, because we're talking huge industries, huge supply chains, huge complexity of orders, of building infrastructure capacity. So it can't be just like on one engine saying the technology is there. It's like, okay, well, how is it going to show up for the industry from the point of view of the business model? And I think some of those things are really starting to come more sharply into focus, that the technology is coming at the right time, as there's been geopolitical things and a realization that there needs to be some movement in terms of the business model. And so these things are starting to come together, which I think is what's really helping shape and move the industry.
Definitely CreateMe has timed this right. But what next? What does the future for autonomous tailoring and garment manufacturing look like? And what kind of technologies do you imagine will disrupt this sector in the next 8 to 10 years?
Yeah, I think, for us as a company, scalability is really important. And these systems are fundamentally built for scale. And I think you can use the reference point of 3D knitting machines, which are great technology, but you're talking about sort of 15, 20, 25, 30,000 units that a machine like that can produce a year. These mass production systems are designed for a million units, but this is an industry that thinks in tens, if not maybe north of 100 billion units. So we're not trying to change everything, but we would love to move. For example, in the US, it's 3% of apparel that's consumed is manufactured on shore. I think I've seen numbers that about 50% of that 3%, so about 1.5%, is for the US government. So move that from like 3% to 10%, there's a huge scalability approach. So we were very focused on building these systems and scaling them and deploying them. And so we will be very focused on these big, large consumer staple, apparel category. I think men's underwear is a natural next step. People care about comfort and the idea of seamless. And that's just as women's underwear does. So that would be a natural place to be looking at, because, you do want to think about what are the consumer benefits for the new type of apparel, not pure economics play. So I think we will focus on those big consumer categories. In terms of other things that I think will happen over the next 10 to 50 years, I see this as actually quite akin to the sort of EV revolution. So if you think about, go back to the late aughts, early 2010s, penetration was very low with EV. But I think, when that first Model S came out, people could see that it wasn't just about being a sports car. It was like across all these different dimensions, a more software-driven approach, model releases, all the amazing software tools, the torque, the range, all these types of things. And people realized it was a fundamentally, I use in simple speak, a better mousetrap. It was a better product for mobility, for commuting. And then you saw over the 2010s, this penetration and adoption. And I think people will realize that bonded apparel is fundamentally a better product. And this shows up, it's not unidimensional, it shows up across almost every dimension. It's a better way to make clothing. And so I think you'll see actually this adoption curve. It's better in terms of the fit, it's a softer hand feel, it's a lighter gram weight, it's better breathability at the seam. You don't have the chafing issues. It looks aesthetically identical from the exterior to sewn apparel. Obviously, there's these benefits from a point of view of how you can automate it. So I think what fundamentally you'll see actually a significant percentage of apparel be bonded over the next 10 to 15 years. I think you'll see double-digit percentage points of apparel. I think the other thing that the technology is going to unlock is this concept of digital manufacturing at a much more scale. So obviously people have talked about on-demand printing. There are certainly companies out there that are doing on-demand fit information, but a platform that doesn't require different tooling for a small to a medium to a large and can digitally adjust how it picks up different panels of different size product is going to unlock and open that entire world. I think it's really exciting from a consumer standpoint, which is always really important to understand how it benefits consumers and customers. There's this vision of mass producing custom fit product or extreme variability. I think, people who might be a little bit odd shapes, they're very petite or very, very tall, those types of things, they have this visceral experience of going to e-commerce things and things being sold out. And I think in this world where things can be digitally driven and much closer, you're going to have this much greater size variability, custom sizes. So I think that's a very exciting vision. And the last point to connect to that is printing companies, the finishing companies that can do all these interesting techniques that people have loved, and that business has just absolutely blossomed in like the last 15, 20 years. If you think of companies like Printful and Printify and Fanatics, and even what Amazon does in that space, the ability to mesh on-demand assembly with on-demand embellishment and have the right thing for the customer at the right time, and not have loads of blanks that, or printed goods that don't sell. That's really exciting. I know, like when they have big sports events, they sort of probabilistically try and determine who's the winner. It's not 50-50, maybe it's 60-40. The idea that you can produce that product for the winning team in like the right volumes and not sell out, that's really exciting. So I think that kind of, to bring it together, I think the kind of consumer end of custom product, what that can do with embellishment, and then just a general adoption of bonded apparel. I think these are all really exciting trends with a lot of headwinds that you'll see over the next 10 to 15 years.
Wow, that's fascinating, Cam. I mean, you've just got me so excited about manufacturing. And I love the passion that you have for it as well. And I guess, looking forward in the next 5 to 6 years, it'll be really interesting to see. And hopefully I'll start noticing when I buy things as well that maybe we have moved away from sewn garments to bonded garments. So I'll be keeping an eye out for that when I go shopping. Now, going a little away from your business and to get to know you a little bit, Cam, where are you from? Where did you grow up?
Yeah, so you can probably hear a little bit of an accent. It's a little bit of a blended accent. So originally from New Zealand, and I have been out of New Zealand, coming up to 25 years or so. So I've been out for a long. I go back. I have family there. All that stuff. I'm definitely a very strong All Blacks. I part of the world that we care a lot about. But yeah, I spent some of my formative years in the UK, went to university in the UK, and then actually started my career in the software side. So I worked at DoubleClick, for a time, at a very dynamic time actually, when DoubleClick, which is an ad tech company, was bought by Google, and seeing the big sort of platform moves there, and then was one of the founding members of a e-commerce platform company that was founded by some of the executive management from DoubleClick, and through that worked in some e-commerce businesses that had exposure to the apparel industry from a software e-commerce perspective, and saw kind of firsthand the complexities of supply chain as it relates to stock outs, liquidation rates, all these kinds of things, and that really got me attuned to to some of the problems in the industry. And I have a background as an inventor, so I've got about 25 patents to my name around the technology. We've got a very strong portfolio. So we've got about just under 100 patents around technology across various verticals, including software, mechanical tools, adhesive. And probably the other part to the story is when I was kind of exposed to some of these issues in apparel from a business model disconnect perspective, shall we say, the very high liquidation rates, it was kind of obvious to me that looking at business model approaches that could allow things to be made closer to consumer, to be made more flexibly for consumer demand. I mean, this is all a period where it's become a much more demand-driven model. You think of the TikTok, generation. That's where these trends are coming from. That's obviously people like Shein have picked these things up. In that world, I realized that proximity, making things close to the customer, was very important. And so I cast it around, in Silicon Valley to, colleagues and associates and friends that were in high velocity manufacturing environments. So to kind of circle back to the start of the conversation, I realized that there were some things that the apparel industry could learn from other industries. And I use that example when we started about, a Nokia phone being soldering rivets and fasteners. Fast forward to, an iPhone, printed laminate adhesive that assembles it. And I could see also footwear as an industry that's a lot more automated. The values of the companies that play in footwear are much higher than apparel. And so I said, there's things that we can learn from outside the industry. I'm fundamentally an outsider into the industry. And so I said, well, look, how can we use some of these manufacturing processes? And that's what's kind of driven our innovation path. And so the head of our engineering he's worked in the apparel industry at manufacturers, but he also, comes from Apple and Microsoft, building things like touch screens with adhesives. So we're used to this high velocity manufacturing environment. I'd say that's been absolutely a part of our story as a company. There's a few companies that are trying to think about new ways to manufacture. What's very different about us is using an adhesive as a cornerstone for assembly, and that's just driven, a phenomenal amount on innovation from a product point of view, as well as obviously from a manufacturing process.
You said you were from New Zealand, and I found out that you were the New Zealand indoor rowing champion.
Yeah.
Tell us a bit about that. How did you get interested in rowing, and do you still go rowing now?
Unfortunately, I don't row much anymore, but I did it for a long time. I had some pretty good successes at the national level in New Zealand, both on the water and off the water. I also rowed at university. I rowed at Cambridge. So it's a sport that I love a lot. And, it's a sport that New Zealand traditionally, outside of sailing and rugby, it's probably our third sport. I don't know, maybe it's because there's a lot of water in New Zealand, a lot of lakes in New Zealand, a lot of rivers. So it's a sport that's very popular in New Zealand. And I don't know, maybe I like the punishment. It's definitely a sport that's about not perfection, but the vision of perfection. Doing the same thing over and over. So it is a sport that sort of focuses on, perfection.
It's great to have a national champion on the podcast then. What are maybe some of the learnings that you've had from your rowing days that you brought into running a startup?
Rowing may have some kind of metaphors or stereotypes that you kind of love pain, that you love the kind of the journey, and that's something that shows up obviously in other endurance sports like cycling. I think running a startup, building a company, that notion of leaning into adversity, leaning into pain to some extent is something that's very important. The concept of resilience is very much there. And I would say actually rowing, like other sports like sailing and cycling and things like that, technology is actually pretty important. And so that kind of perspective on the boats used are very, very advanced. They're extremely lightweight. They're all carbon composite shells. Things about how you can comport your body to drive force, because force around a pivot. So there's kind of engineering principles, are things that you certainly attune your body to and your mind to in rowing. There's certain angles of things that are going to put more force or pressure. And so that kind of mindset of thinking about efficiency and principle engineering, obviously things in a company like ours that are really important. And it's not obviously one-to-one translatable, but a mindset. I think it's been very helpful. Yeah. Sorry, just one more thing I would say about rowing to something. So sartorially, rowing, it has this great history of rowing blazers and jackets and things like that show up when you're awarded. So, I did also have some kind of exposure to apparel and fashion, through that as well.
Running a startup is extremely painful and it's a lot of blood, sweat, and tears. There's moments of huge success, but there's more moments of failures as well. So are there any favorite failures, projects or experiments that didn't work out as you planned at the time, but ended up opening new doors or new opportunities that were otherwise overlooked?
Yeah, I think there's certainly a lot of that. Failure or spinning your wheels or kind of that pressure, is part and parcel of startup life. I would say that we spent a decent amount of time on our journey, focusing more on automation solutions around embellishment earlier on in our, not just automation of assembly of the underlying textiles, but automation of how different embellishment techniques, because if you take, for example, printing, it actually has sub-elements to it between a pre-treat solution that goes on, how it gets printed and how curing systems work. We spent time in that area. I think one of the things we learned from that is maybe twofold. One, the printing or embellishment space is a much more sophisticated, much more automated part of the value chain already, in apparel. And so, said another way, the opportunity to make an impact is actually smaller because there are some really great companies that have done, really, really great things. And so looking at kind of blue ocean is maybe bigger. I would say also just to lift the comment up a little bit, I think the art of being successful, in my personal opinion, in a startup and building a real company that has longevity, compounding is really important. And so it doesn't matter so much if you're making, small mistakes or even quite big mistakes on the time. It's like the resilience of keeping on is so, so important. And this kind of concept, if you can be like 1% better or even 0.5% better each week, but you compound, do the math, that is very true. And I think people that are working in physical innovation in physical industries, in which hardware obviously is, this idea of compounding is really important because, you will build hundreds of prototypes. Many of them will fail, but you will learn a lot and it'll get better. So this idea of building and iterating is very important. And, hardware, that expression hardware is hard.
Yeah.
It takes a lot longer than software when you're dealing with atoms and not just bits. And so this idea of resilience and kind of these small improvements, but week on week, month on month, year on year, compounds over time. And that's why hardware, when you've built it out and you've gone through 1,000, 1,500 process tests and 200 prototypes, and you built the IP, the foundations, the solidity of that innovation is incredibly strong, because you have all this knowledge that can turn up in patents, but you have also all this kind of process engineering, this tribal knowledge that doesn't turn up, and it's not very easy to replicate at a hugely grand scale. And NVIDIA is this great example, right? So they've built for a long time. GPUs became sort of quote unquote sexy in the mid 2010s, but they were on this journey for a long time before that in video games. And so their infrastructure, their knowledge in designing chips and how they get built, how you integrate software with hardware. There's no hardware product is purely mechanical. There's always controls, there's always software that goes with it. This builds this really strong position over time, but you definitely get taught along the way all the painful things when you go wrong in the physical. When you go wrong in the physical, it's very visceral versus a software bug or something crashing.
I loved the way you talked about compounding effort and how that really takes off after a certain point. And great advice for other hardware startup builders, especially in textile manufacturing. There's, some activity in that space that's starting to pick up, and hardware is hard, as you said. So it's a great bit of advice there. So we talked about constructing garments, and, fashion is beyond just the performance of the garment. It's about identity. It's about emotional connections. And this is a question I ask all my guests. Could you share with us about a garment or a piece of textiles that holds deep personal value for you, something that you hold on to, that has a personal story that's connected to it, if you're happy to share that?
Connecting back to that comment I said about rowing actually having quite a tutorial connection. So many people, who are not rowers might not know this. There's a peculiar thing in rowing, that the award for great achievement often is a blazer, a very colorful blazer for winning. Like obviously they talk about that in golf at the Masters. Well, that concept, that idea that's used in the Masters, that actually comes from rowing, and so you can win particular blazers. A blazer as a garment comes from rowing. You can win particular types of blazers, certain colors, certain trims, based upon achievements that you make, and that happens both at high school, university, and the club level. So I do have certain blazers, in my kind of collection that have a lot of sort of emotive value to me from points in that kind of career, as it were, and athletically. So that would be something that's very special, and it's.
Oh, I love that.
It's a little ecosystem, or a little world that it thrives on extremely bright colors, and that's also quite fun as well. Orange colors, most garment combinations somehow seem to work together, and that's very much a part of.
Oh, I'm going to have to Google this and look at some of these blazers. They sound fascinating. So this question is actually from my previous guest, Amanda Parks. She's the CTO of Mothership Materials. And so she's left a question for the next guest, not knowing who that is. This is her question. I think it's a good one for you as well. Textiles are central to us and is part of many supply chains, agriculture, manufacturing, materials, and it impacts, very much how we live and work. Yet public perception often treats fashion and garments just as trends and styles. So how can we shift that narrative to recognize textiles as a vital part of our daily life and technological innovation that it is, similar to food and the automotive industry, etc. So in your career, how do you think about changing this perception that people have about clothing? And what steps can the industry take to bring this deeper value to the forefront of the public consciousness?
Yeah, I think that's a great question. I think narrative storytelling is really important there. To pick up on a couple of concepts that you talked about. So I love this little notion that when you think about the apparel industry, everyone in the world is a customer. And when you sit back and you think about it, of course, right? Everyone has to be clothed. But it's little mental models like that to remind us how ever present apparel is. Everyone is a customer. So I think that's, these like little narrative, hooks, again, about self-identity. I think there's something you mentioned about self-identity or expression. Clothing is the most personal. It is the most fundamental, the most intrinsic way that people have self-identity, and expression, for who they are, both in terms of the silhouette. You think of uniforms across many, not just the military, but many different things. Occupation you have is self-defined by what you wear. So even if you think about industries that are kind of anti-fashion, I'd say the tech industry of having, I always think of punk. The joke is that they were so anti-establishment that they made their own establishment, because having your own identity, which is an anti-identity, but it kind of falls apart because it becomes its own identity, that you have to have pins on your jacket and you have to, sort of have holes in your jeans and you put studs on your clothing. And so this concept of identity, I think, thinking about that is really important, because I think, expressing who one is, is a very important thing. So I think those kinds of hooks are very, important, and I think the impact of apparel, I think, whether that's in terms of the scale of the industry, as I said, I think that's a stat that I talk to a lot of people, they're very surprised by, that the manufacturing output, so that's really the intrinsic importance of this as an industry, maybe not monetarily, but from just a sheer scale of an industry, it's the second largest in the world in terms of the number of units that are produced. So I think having these narrative hooks are very important for people to reset the impact of the industry. Again, if you take things like certain parts of the industry, from a sustainability perspective, that's an impact as well. It's not a good impact, but we should change it. And so I think these narrative hooks are very important. So I can give you one last example. One of our investors talks about and he's done this very, very publicly on podcasts and things, talks about the impact of the apparel in a negative sense in terms of liquidation. He says, what would the world say if 35% of Ford 150 pickup trucks went straight from the factory to the dump? There would be a shock, but what goes on in the industry. So I think these narratives, hooks of storytelling are very powerful about where the industry needs to move, but also where people more broadly need to understand the really positive impact that it makes in terms of self-expression, identity, or just how it impacts across so many different stratas of life. So I think storytelling is always a really great way, because it's something like apparel, it can kind of fade into the background, ironically, because everyone's wearing it every day.
Yeah, exactly.
It is in one sense a commodity, but obviously not in another, because brands are so important. So I think storytelling is very important to crystallize these kind of big abstract trends and things like that.
Yeah, and also to help people understand the complexity of creating a garment. I mean, because, like you said, it's so ubiquitous, it's everywhere, that people don't realize how complex just engineering a shirt or a blouse or a t-shirt is. And we've just spent, all this time talking about how complex that system is, and, how difficult it has been to automate that industry because of how complicated it is.
Yeah, I would agree with that 1,000%.
What question would you like to leave for the next guest?
I would say So I think you have lots of very interesting innovators on your program, but to what we've just been talking about, the industry is very abstract, and I mean that in many senses, because it's like this ubiquity has actually kind of created some abstraction, because where things get produced, the manufacturing process, further upstream materials, the stuff just shows up proverbially at your door. Innovation in this area tends to be quite complex, and it touches lots of different things. It's like the opposite of, like when the iPhone came up, and you don't have a keyboard anymore. You can use your finger to manipulate it. That's like something you could explain to a 3-year-old. But I think a lot of the innovation that I see, and there's some great innovation. I'm a little bit familiar with Mothership, and obviously a lot of people across the material science. I would ask, how do you communicate your innovation in such a way that it be understood very, very broadly to people outside of the apparel industry? I would say that's a really great thing to go after, but it's quite tricky to do because of the types of innovation. There's so many steps in the value chains that a lot of these things, like how do you show where the impact shows up for someone that's not in the apparel industry? I think these are great things to pause on. So that would be my question. How do you communicate these great innovation ideas, but they're often quite abstract, and the average person outside of apparel probably only spends less than 1% of their time probably thinking about some of these things, even though they have a big impact. So that would be maybe my question.
Brilliant. That's a great question. Well, Cam, thank you so much for your time. That was absolutely fascinating, mind blown. And I wish I could just walk into your factory and see how all of this works together. But I know there's some videos online on your website, which was really helpful. Definitely going to be keeping an eye on where things are going to go for you guys, and wishing you all the best in sort of starting to scale this up and really showing the impact of what this technology can do. And I also wonder whether one day one of your robots can be in the London Museum's sewing machine, alongside the first invented sewing machine as well. I know there's no sewing involved here, but it's just nice to see the evolution of constructing garments. So thank you again, Cam, for your time. Just opened up a whole new world for me, apparel manufacturing.
Absolutely. Thank you very much, man. It's great to share what we're doing with the audience. And I think it's a really nice point to close on, the idea that maybe there could be this handshake, in a museum about, passing the baton as a...
Absolutely.
I love that idea. Great. Thank you.
Wow, that was absolutely fascinating. It blows my mind when we really pause to think about fabrics and sewing. And these are the most mundane materials and acts of construction. But if you really think about it, if you really pause and think about it, fabrics are such complex materials, and the very simple act of sewing, I say simple, but it's actually such a sophisticated method of construction. Cam really pulled back the curtain on just how complex, labor-intense, and globally entangled the apparel manufacturing really is, and why the industry is ripe for transformation. CreateMe's Stitchless adhesive-based construction and physical AI-driven robotics is all set to radically transform the apparel sector with high-precision engineering, enabling on-shored microfactories, faster lead times, and reduced waste. The sewing machine is a remarkable piece of technology, and I don't believe that it will become obsolete. But I do believe that autonomously made stitchless garments will be in our wardrobes in the very near future, so do look out for it. If you'd like to learn more about other advanced textile manufacturing technologies, I can recommend a couple of past episodes we've done. We had Gilberto Loureiro from SmartX AI sharing with us about AI technologies that's used for detecting defects during the manufacturing process, and this can lead to reducing huge amounts of waste during textile production. And this is episode number 6. And in episode 13, we have Beth Espineta sharing about Unspun, another Silicon Valley startup. Their 3D weaving technology constructs 3D garments on the loom and is looking at similar concepts of onshoring with zero inventory, on-demand production at microfactories. You can find the links in the show notes to these episodes, or just scroll down on your podcast platform and these episodes should pop up. So that's episode 6 and 13. If you're interested to visit the London Sewing Machine Museum, I'm definitely making a trip there. I'm so curious about this place. I have left a link in the show notes for more information. Apparently, it's only open once a month, so do check out the dates before you head there. Please share the episodes with anyone who might find it inspiring or valuable. Your support to spread the word about this podcast is deeply appreciated. If you enjoyed this episode, consider buying me a little coffee using the link in the show notes. Buy me a coffee. It helps fuel those late night editing sessions as I bring you these stories. Thank you again for joining me. Stay tuned for more episodes and don't forget to subscribe for more conversations at the intersection of textiles, emerging tech, craft, and sustainability. Until next time, I'm your host, Mili Tharakan, reminding you that there's no such thing as ordinary cloth. Every thread tells a story.